Now let's do something a little sneaky. Suppose I have a class called puzzle, and it has two overloaded methods. One is peek, which peeks at list 61b's, and it prints out the last item in a list 61b. I also have a method called peek, which takes slists and prints out the first item. So my puzzle for you is as follows. Suppose I have a variable of static type slist, sp, and I set it equal to a new slist. Okay, so its dynamic type is also slist. Then I create a variable of static type list 61b, and then give it dynamic type slist. And they're pointing at the same object, and we fill in elk are cool. Okay? So if I call the method peek sp, and I call the method peek lp, the question for you is which of these methods get called? In other words, what gets printed? So think about that for maybe 30 seconds to a minute. Or however long you want. I mean, that's not live lecture where I make people take a certain amount of time. Okay, so we just did all this work and we said, okay, well, if there's like overriding, we just use the slist class. So obviously it's just gonna be, let's see, the slist. So it's gonna print out elk twice. Okay, nope, wrong. So why? Well, Josh, you should be complaining. I thought you just told me that there's a simple set of rules and you'll set me straight and I won't get confused. Well, I tricked you a little bit. This is overloading, and what we did before was overwriting. And I want to draw this distinction in a tricky way because I think this is where students get confused. Okay? So what happened here? Well, when it comes to overloading, we don't do dynamic method selection. Instead, when the compiler compiles the code, it says, okay, here's a peek method, right? There's one here that matches the signature. It just says, I know I have an slist, a variable of static type slist, so I'm going to call slist when I get to this point. The compiler also says, well, when I get to this point in the code, I'm going to compare the signatures. I'm going to say I have a method for lists and a static type variable list, so I'm going to do that when I get there. So in other words, the compiler, before it starts running, decides this is what it wants. It wants to call the slist oriented method up top and the list 61b at the bottom, and by the time the code actually runs, we get elk and cool. All right. So let's draw the distinction between overriding and overloading. Dynamic method selection only happens for overridden methods. And that happens whenever an instance method of the subtype overrides some method in the supertype. So for example, with slist, we had print, and that overrode a method in the list 61b interface. So print is a great example. Make noise for animals, maybe. So that's overriding. So if I ask a variable, like if I have a pointer to a variable, and I ask that class itself, hey, would you like to do something? It will say, great, I got it. I'm going to use the most specialized method I have available. This does not occur for overloaded methods. So this is, for example, when a class has 2 methods or 3 methods or whatever, one for the supertype and one for the subtype. Okay. So here I have slist, list 61b, set, and so forth. And so in this case, even though this is a subtype of this supertype, if I call peek with overloading, we use exactly what we say we want. Okay. That's just how Java was designed. I think it's actually a pretty sensible reason, but we won't pick it apart in this lecture. Now there's obviously interactions between these. On the discussion worksheet, number 4, this will be available. There's also some Gorilla section work you can do to understand this better, but those are the basic rules. Dynamic method selection happens for overriding, not overloading, and that's pretty much as deep as it needs to be.